converting measurement units, and we're really going to look at the idea of dimensional analysis. So we talked about in class the different types of systems that we look at. We go capacity, where we had, let me grab a different color, 8 fluid ounces, FL, not FC, FLOZ equals 1 cup, 2 cups equals 1 pint, 2 pints equal 1 quart, 4 quarts equal 1 gallon. And then we talked about that being our capacity system. Then we got mass, where we talk about 16 ounces. Notice the difference between ounces and fluid ounces equals 1 pound. We've got 2,000 pounds. Pounds, there we go, equals 1 ton, little t, by the way. And then we talked about our length units, where we had 12 inches equal 1 foot. All these things are things you probably remember off the top of your head, that 3 feet equal 1 yard, 1,760 yards equals 1 mile, and then 5,280 feet. 80 feet equals 1 mile. I don't know why my M is so tall. There we go, a little better. So when we talked about that, we also talked about our metric system, where we talked about King Henry died by drinking chocolate milk. And we talked about how these are each based on the tens system. This is kilo, hecta, deca. This is our base unit, and we'll talk about those at the end. Deci, centi, and milli. Each of the ones with ending in i's have are less than 1. So we said the base units are grams, that's for our mass. Then we have capacity, which is a liter. And finally we had our length, which is a meter. Okay, these are our ones. A deca is 10 times bigger than a base unit. Hecta is 100 times bigger than the base unit, or 10 decas. 10 hectas equals 1 kilo, and that's 1,000 times bigger. And then down below, it's 1/10 of a base unit, 1/100th of a base unit, or 1/1000th of a base unit. Everything is based on the 10 system, so it's much easier to convert between the two. We're going to focus mainly on the capacity system, because that's or the customary system that we're looking at, or the standard system. So a couple of things we need to have in the back of our head is the idea of what a unit ratio. You might have heard the word, you've seen the word unit rate. They're very similar. But unit ratio is just a rate for a single item. It's a slightly different version than a unit rate, because we're talking ratio, because we're talking comparison between two different things. And then we're going to use the dimensional analysis process, or talk about it is the study of between two different types of units, how to convert from one type of unit to another type of unit. You can always pause this video anytime you need to get those vocabulary written down. So if we talk about converting feet to inches, the first thing we're going to talk about is how to set this up. We're actually going to use our fraction knowledge. And we're going to set that base, we're going to kind of think about how we do a problem like 3/4 times 6 over, say, 9. Let's make this a little different. Let's make it 8 over 9 instead. And how we know that since these two share common factors, we could cross-reduce them down to 1 and 3, and the same with here, down to 2 and 1, and we'd end up getting our answer being 2/3. Well, the idea of cross-reducing doesn't just apply to numbers. It's going to apply to our units as well. It's something you had to think about back when you were talking about area. Okay, when you had 2 feet times 6 feet, you knew the answer was 12 feet squared. You couldn't get rid of them. You had that squared because you had 2 units multiplied together. So we're going to talk about how we kind of use that knowledge and that thought to build our way from here. So we're going to start with putting 20 feet as a fraction. 20 over 1. There's a couple different ways you can do it the railroad track method. If you want to, that's one way, or you can just write them as fractions. Either one works for me. I'll do them both ways. I'll switch back and forth. But the key to dimensional analysis is knowing, okay, now here is going to be my unit ratio. And we look back at our notes, we look at, okay, it's feet. We want to go from feet to inches. So the key to this is we're going to use that same idea we used right here. We divide it by 3 to simplify the problem. We're going to do the same thing, but instead of worrying about the number, we're going to get a way to cancel out the feet. Okay? So to know where my unit ratio goes, to know if I multiply or divide, if I'm going from bigger to smaller or smaller to larger, the easiest way to do it is to set up my unit where the one I want to get rid of is feet, is diagonal to each other, okay? Because what that allows me to do is do that same cross reducing I did here. And then my other answer is inches up here. So now we fill in our blank. We know that 1 foot is 12 inches. So we can cross reduce our labels this time. I know that's a big difference of what we've been talking about, but you can cross reduce labels just as easily as you can cross reduce numbers. That means I don't have feet over feet when I multiply. I'm going to have 20 times 12 inches to get 240 inches. That's my final answer. Okay. Go ahead and try converting 2 miles to feet. Remember to use your method. Set up your railroad tracks, okay, and take a look at how it works. All right, so let's take a look at how you'd set that one up. We'd start with our 2 miles here. We know our conversion from miles to feet is 5,280 feet to 1 mile. My key is having my miles down here. That means feet must go up here. So I have 5,280 feet here and 1 mile down here. These cancel because they're on the same line, and then we multiply across to get 10,560 feet. 1 times 1, we put a 1 here if we want to, but there's no need to because we know it turns into 1. And there's our final answer. But the key is getting rid of these 2 units. That's how we set them up. Now, let's take a look at how fractions work. Fractions kind of work the exact same way. Since we've been using our fraction concepts, it makes it really easy to work with fractions. The biggest thing is we remember that our units go on the top. So if I have 1 over 4 cups goes up here. So as I work my way through it, I'm going to say how many, there's my first piece. Fluid ounces, there's another key unit I need for the answer. Here's my question. And then per is my keyword, like we talked about with our cube strategy before. So that means multiply fluid ounces. So that's what I want to get to. So think back to my ratios I know. 8 fluid ounces equals 1 cup. So again, my cups go down here. My fluid ounces go on the other location. And I'm going to fill them in number 8 to 1. So I cancel out what I can cancel out in units. Then I look, do I have any numbers that cancel? And this time I do. I can divide them both by 4 and be left with 2 and 1. So when I multiply across, 2 times 1 is 2, 1 times 1 is 1, fluid ounces, put my periods there for my abbreviations, and there's my final answer, okay? So I want to go ahead and, even though this one's a now you try, I kind of want to talk about it because we haven't talked about converting decimals to fractions yet. So one of the things we talked about is thinking, okay, here's my label, here's the ounces, there's the keyword I need, how many will she make? Here's my question, and then how many we know we're talking about converting, so we say how many we're going to multiply. So the first thing I would think is, how do I convert 1.75 or 1 75 hundredths to fractions? So think about 75 hundredths. If we kind of think about this in money, how many quarters is 75 cents? Okay, we've got 3. So I could rewrite this as 1 3/4. Even says it sounds like that. And then anytime I've got that mixed number, I've got to switch it to an improper fraction to solve. So 7 over 4. Again, I'm going to do it the other way this time. We just as like fractions. And then since I've got pounds on top, I need pounds on bottom, and I want to go to ounces. So this is OZ. So I know I have 1 pound is 16 ounces. So I'll cross reduce again. Goodbye labels first. Cross reduce my numbers to 4 and 1. 7 times 4 is 28. Again, it's over 1, but we know anything over 1 is just a whole number. And I'm left with ounces as my answer. Okay? All right, I want you to try converting 15 quarts to gallons. I'll give you a couple. Go ahead and pause the video and see what you come up with. All right, so it's that same process. 15 quarts times. Then we got to go our quarts to gallons. We think back ourselves. We got a quarts here on the bottom. Going gallons here on the top. And we're going to say 4 quarts is equal to 1 gallon. So I was able to cancel out my quarts. 15 times 1 is 15. 1 times 4 is 4. Now I can simplify my mixed number, or my improper fraction to a mixed number, and I get 3 3/4 gallons. By crossing out my abbreviations, I know I'm at the right label. Okay? All right, go ahead and try our cups to pints conversion. All right, so let's take a look at this one again. So it's that 11 cups. Go back to the railroad tracks for just a second. So I need cups down here. I need pints up here, because that's what I want to end up with. What I want to end up is by itself. These two will cancel. That's what I need. 2 cups is 1 pint. So 11 times 1 is 11 over 2. We're going to simplify that down to 5 1/2 pints. All right, let's try a couple more word problems in this and see how we come up with. So Yumiko needs 4.5 yards of fabric to make a costume for the play. How many yards of fabric does she need? So again, we got to go, okay, there's 4.5 feet. All right, well, I can't work in mixed numbers, so I'm going to go ahead and make it improper. And then from here, I'm going to say, okay, my key here is, there's my word. Yards is my other unit I need. How many tells me multiply. Okay, because it's a conversion problem. All conversion problems are multiply. All we got right now. So we go, okay, I need to get feet down here. I'm going to yards. So there's my yards. I know 3 feet equals 1 yard. So I'm going to multiply again, cross reduce. Hey, I can cross reduce my numbers down too. So I'm left with 3 over 2. And I'm going to simplify that to 1 1/2 yards. Well, I guess I should put an S on that since it is plural. All right, go ahead and try this next one on your own. See what you come up with. See how many yards Tracy kicked the soccer ball. She kicked it 100 feet. Pause the video and see what you come up with. All right, so again, that same 100 feet multiplied by our conversion. Feet has to be on the bottom. Yards is on the top. We're going to say that same conversion. 3 feet, 1 yard. I can't cross reduce this time, so I'm just going to have to multiply. 100 over 3. Cross off my units. So 100 goes into 10 3 times, 1 left over. 100 goes 10, 3 goes into 10, another 3 times with 1 left over. 20, 33 1/3 yards. So she kicked it about a third of the way down the soccer field, or down the football field. All right, now you kind of got that idea. That'll help you work through the dimensional analysis. Good luck. If you have any questions on your homework, please come see me Monday morning and we'll happily talk about it. Have a great day.